Okay, good day, everyone. My name is Nada Talabzadeh. I am a VDC project manager at Entech Engineering. Today, I'll be presenting on becoming a full bridge designer. And I really hope this presentation will provide insights into the workflow, tools, and skills necessary to advance in bridge design using Open Bridge Designer. So to give you an overview of today's presentation, I will cover our general project workflow, my journey with MicroStation, and how I advanced with OpenBridge Designer. Toward the end, I will share some case studies that I developed entirely in OBD. So I'll start by introducing myself. I have a master's in structural engineering from NYU and a bachelor's in civil engineering from Beihang University, and that's in China. Some of the key projects I worked on include JFK Airport's new Terminal 1, JFK Central Terminal area for roadways, utilities, and ground transportation center. Another one is Penn Station access, the widening of Van Wyck Expressway, and Lincoln Tunnel helix replacement. I also have over 5 years of experience in VDC beam and structural engineering. Also this year, I was recognized as a rising star in the AEC industry. And about my daily tasks to give you more insight, I lead projects and I make sure that we develop accurate, coordinated, and high quality designs. So, as I mentioned, I work at Entech, and we are an engineering and technology company with expertise in areas including but not limited to civil engineering, geotechnical engineering, VDC beam services, and so on. We have been recognized as a top design firm, and we also have over 300 local professional staff based in our New Jersey and New York offices. Our commitment is to advance engineering technology and digital solutions for our clients. So here in this slide, you are looking at a high-level overview of the workflow that we usually follow in our projects. In general, it begins with model authoring, where we use MicroStation and OpenBridge Designer to develop our models and generate drawings. Then we reference all trade models into the project master model, and then it moves into reporting the clashes and coordination among the teams. And that's where we usually use iTwins and Synchro in some cases. And of course, based on the clashes, the design gets updated accordingly until they're all addressed. But this could be slightly different case by case. In general, we use various tools and techniques at each stage of the project to meet the standards. So, as we all know, for every project, drawings need to be generated for design development, coordination, and documentation. My journey earlier in my career began with learning MicroStation and 2D tools. Then I gradually progressed to creating sheets from scratch, following the agency's standards, attaching survey files, and customizing tools for myself. And I would say within a few weeks, I felt more comfortable with the tools. And I continued to learn new features as the projects advanced. One aspect of MicroStation that I haven't yet explored, but I am very eager to try, is basically creating custom plugins for specific tasks. It could be different tasks to tasks, but I believe if certain tasks could be automated, I believe it could make a huge difference and could be a significant time saver on projects. So moving from MicroStation basics, I had a project that required the design and modeling to be done in OpenBridge Designer. So I started exploring the software, and soon I realized it's a very powerful tool for every phase of a project, even including clash detection and reporting. One strategy, though, that really helped me in the beginning was prioritizing learning the tools for designing the bridge superstructure first, then moving on to the substructure. This actually made the learning process easier and a lot more efficient. So for me, I spent a lot of time on Bentley's YouTube channel, and I looked into the resources there, especially the videos posted by Alex. I really found them extremely helpful because he shows the best practices and provides details about functionality of the tools. And I myself also try to just stay up to date with the latest OBD releases and the new features that they provide. For example, my favorite update in OpenBridge Designer 2023 is actually the ability to downgrade the files to older versions if necessary. I know we're all always, cautious about opening files with different software versions. So this new feature has really been a relief. And if you mistakenly open a file with a later version, you don't need to worry about it. You can downgrade it if you need to. So now I want to show you some of the projects that I developed from scratch in OpenBridge Designer. Each of these case studies had their own unique challenges. For example, the one you see on the screen, this is a three-span railway bridge. I remember this one. This one was one of the first major bridges that I developed in OpenBridge Designer, which had a particularly complex geometry, sloped deck, skewed framing, and non-standard bearing sizes. So everything about this bridge really felt like a challenge. And at the very first, it just seemed nearly impossible to find the right tools to model these unique elements, especially since the general library didn't have the components I needed. So I clearly remember that day. I was just sitting there staring at my screen, thinking, how am I going to be able to make this work? But that's when I realized something really critical about working in this field. Sometimes you just have to innovate. Instead of searching long hours for pre-made elements, I just decided to create parametric cells from scratch. I manipulated the constraints, adjusted variables, and explored the alignment tools to just follow the exact slope I needed for the project. But the breakthrough moments came when I realized I could actually use the smart features in OpenBridge Designer to model the surfaces and solids. It wasn't really about just relying on what the software gave me, but using the tools creatively to generate something truly custom. And that was the turning point for me when I realized that no matter how complex the challenge, the software combined with creative thinking can always find a solution. So this bridge in particular took me approximately 2 months to complete. There are different parameters that can affect the time frame, but reading and understanding the as-built drawings for this case was a challenge itself. They were just so old and the information was faded, so it took me a while to get myself around this case. But it definitely, I would say, pushed me to learn new features, and it was a great experience. Another challenging bridge that I worked on was this two-span railway bridge with a sloped deck and girders that didn't really follow the exact same slope of the deck. And this bridge also had a very unique abutment geometry, as you see, and with sloped ties and different bearing sizes. And again, none of these were available in the standard OpenBridge Designer library. So I had to get creative to achieve the right geometry for this case. Um, I would say the most difficult part was designing the parametric cells for the abutments. I needed to just make sure that if the dimensions ever changed, all the parts would update proportionally. So I was very careful about setting and adjustments and making sure assigning the attributes right. Um, on this case, I also remember that I used civil alignment tools to follow the correct curved slope for the deck. And on top of that, I had to generate different deck levels to just position the framing right in space and, of course, accurately. This one is also a similar case, similar bridge with similar abutments, but it wasn't exactly the same, of course. This abutments were unique, you know, and the walkways, the approach slabs took me some time. The girders, because they're huge, and of course, for here this case, I had to manipulate the ACS several times to just get the right angle for the tieback system. And I remember that I used this smart solid frames a lot to get this done. These two bridges, I would say, really tested my problem solving skills, but it taught me the importance of leveraging every tool available, even if it means going beyond the standard features. It was just a great reminder that sometimes the best solutions come from pushing the boundaries of what the software is designed to do. So this final case is also a two-span railway bridge. The main challenge here for me was the slope of this roof structure in two directions. In this case, other than creating parametric components, I used curve utility tools to assign adaptive points to just be able to adjust the roof geometry. Not sure if you ever tried working with the adaptive points, but it was very useful for me because it just gave me the flexibility to manipulate the surface and have an accurate representation of this roof here. So that's pretty much it from me. Thank you for your time today. Please feel free to connect with me through email or LinkedIn. I'll be happy to discuss more about bridge design and VDC beam processes.